All right, today we are going to look at section 12.1, which is sequences and summation notation. So we have a few little things that we need to learn about different sequences, some notation, some finding some sums, writing different ones, and then looking at sigma notation. So we'll just start with the definition of a sequence right here. So when we look at the definition of a sequence is a function A. Well, it doesn't have to be called A. It can really be called any letter you want. We're just going to use A, whose domain is the set of natural numbers. The terms of the sequence are the function values themselves. So remember when we do function values, we would do like A1, A2, we could keep on going, and this could keep on going forever until we get to what we would call maybe A to the n. Okay, so that's where you're plugging in that number into the function and getting out a value. We are usually going to write, instead of writing our function values like that, we're going to write A with a subscript n. Okay, instead of the function A to the n. So we're just changing notation a little bit. So the terms of the sequence are going to be written as A1, A2 with little subscripts instead. A3, we could keep on going for however many we have until we get to A to the n. So in general, our A1 is called the first term. Our A2 is the second term. So in general, our A to the n subscript is called the nth term. Okay, so we'll be doing several different things with this. One thing that we're going to do right here is find the terms of a sequence. So we want to find the first 5 terms, and then we're going to find the 100th term. So whatever term you want, that's the number we're going to plug in. So to find our first 5 terms, that means the first thing I want is A to the 1. So everywhere there's an n, we're plugging in a 1. So this would be 1 squared minus 1, 0. My second term, A squared, is, 2 squared minus 1 equals 0. Oh, doesn't equal 0, just kidding. 2 squared minus 1 would be 4 minus 1, so this is 3. A cubed would be 3 squared minus 1, so 9 minus 1 is 8. Our fourth term be 4 squared minus 1, so 4 squared 16 minus 1 gives us 15. A to the 5th, 5 squared minus 1, 25 minus 1 is 24, so there's our first 5 terms. So then we also want the 100th term, which means now I want A and I want the 100th term, so I'm just plugging in 100. So this would be 100 squared minus 1. Might want to use your calculators for this one. 100 squared minus 1 is 9,999. So there's our first 5 terms. Do it again. Notice here I said A to the n. Notice in part B it's C to the n. It doesn't matter what variable you use. It could be any letter, just the n, you're just plugging in. So again, if I want the first term, C1, this would be negative 1 to the first over 2 to the first. So negative 1 to the first power is still negative 1. 2 to the 1 is 2, so negative 1/2. Our second term would be negative 1 squared over 2 squared. Well, when I square a negative number right here, it becomes positive. So this now becomes a positive 1. Square my 2 on bottom is 4. My third would be negative 1 cubed over 2 cubed. Well, negative 1 cubed, if we cube a negative number, I could get a negative number out. So this would be negative 1 over 8. Okay, same thing. We can do our fourth term. So our fourth term on here would be negative 1 to the 4th over 2 to the 4th. So any negative number to an even power comes out positive. 2 to the 4th is 16. Our fifth term, negative 1 to the 5th over 2 to the 5th. So again, negative 1 to the 5th to the odd power makes that a negative 1. And 2 to the 5th power is 32. And then we're going to do the same thing with 100. So we're going to have negative 1 to the 100 power over 2 to the 100 power. Well, negative 1 to an even power is a positive 1. 2 to the 100th power, if you put that in your calculator, you get a scientific notation number. Okay, so when we write that, that is a really big number with the scientific notation. It's okay if you go ahead and just leave it as 1 over 2 to the 100th. instead of writing scientific notation. We haven't spent a lot of time on scientific notation, so I'm not going to make you write your answers that way. So you might be asked to find the first few terms, might be fine to find a certain term like the 100th, whichever one they ask for, that's what we're going to plug in. Another thing we're going to do with sequences is we're going to work backwards. So here we're going to find the nth term, which means I want to write something that looks like our examples from up here from example 1. Our answers are going to be like what was given to us up here. So we want to find the nth term of a sequence whose first several terms are given to us. So what we're going to write, we want it to write, look, a to the n, and we have to figure out, well, what's it going to be that when I plug in a value, I get what's left here. So kind of look for patterns. There's different things. If I look here, you can see that I am adding 2 in between each of them. Okay, well, you're adding 2. So, okay, well, then say, well, it's n plus 2. Well, plug back in and see if it works. You always start with a 1. Well, if I plug in my first term and I plug in 1 here, that would give me 3. Well, my first term is 2. So that's not right. Okay, so we have to look for something different. Okay, so let's try again. So, well, if I look at it, I'm multiplying by 2. 2 times 2 is 4. Okay, or 2 times 4 again would give me 8, so that skips the 6. Well, that doesn't work. So have to think about something else. You're just trying to look for any patterns that might help you that look at it. So if I think about this, if I want my first term, that means I'm plugging in 1. Well, 1 times 2 is 2, right? Then if I plug in, so if I plugged in, let's say I take my first value and I'm multiplying it times 1 when I'm substituting in. A2. Okay, well, if I plug in 2, so if I did 2 times 2, this gives me my 2, this gives me my 4. If I wanted my a to the third, that would be 2 if I'm plugging it in, 6. So 2, 4, 6, this is working. So notice this is what I'm plugging in, so it's my variable, so this is just 2n. This sometimes takes some time for you to look for a pattern. If I were to keep going, that would work. Okay, part B over here. The first thing I want you to notice in your notes, you are missing this -8. You need to put that in there or there's no way to solve this sequence. Okay, I accidentally didn't type in that -8, so make sure you put that in there. And then we are going to, again, write it with our a to the n. So the first thing you notice is it goes from negative, positive, negative, positive, negative. Whenever you have that pattern, you automatically are going to put a -1 to the nth power. Because then to the odd powers will give me negative, the even powers will give me a positive. Then we have to figure out, okay, that's going to take care of the negative positives in here. What is going to take care of getting a 2, 4, 8, 16, 32? So we just might have to do trial and error again. So kind of think about it a little bit. So when it's kind of going up quicker like this, I'm not multiplying by the same thing every time. I'm not multiplying, I'm not adding. So it's probably going to be an exponent of some kind. All of these are like 2. So think about like 2 to an exponent. Just start with 2 to the n. Well, if I wanted my first term, that would give me -1 to the first times 2 to the first. That would give me -2. If I plug in my second one, it'd be -1 squared times 2 squared. So this would give me my positive. 2 squared is 4. Check at least like the first 3. -1 cubed times 2 cubed. So this gives me my negative. 2 cubed is 8. And so forth. So this would be our answer, finding the formulas. Again, it takes some time, some trial and error. Think about it and see what you can come up with. So those are the 2 things that you are going to do with sequences in that notation. Our next notation that we're going to look at is called sigma notation. So sigma notation uses it's a Greek letter right here. Okay, it's called sigma. That's where we get it from. So the symbol is like a capital E. It's used to indicate addition. Okay, the symbol is the Greek capital letter for S. So it's the Greek, didn't leave you enough room here, capital letter for S, pronounced sigma, which stands for sum. Okay, because we're going to be summing things together. So using this notation, we're going to have the sum, and we're going to go from some variable. I'm just going to put an I right here. That's not a very good I. Let's try that again. I equals 1 to some number. We'll just say n again like we did before. of some function, so I'm going to call it AI. So when you do this, whatever letter's down here in your sum needs to be the same one that's up here in your sum. A lot of times you're going to see it be the letter K also. It doesn't matter what letter it is, okay? This is going to stand, what this means, to stand for the sum of adding all of your terms that we just found together. So you're going to have A1 plus A2 plus A3 plus all the way to whatever our top letter is, which is A to the N. So now instead of just finding the terms, we're adding them together when we have our sigma. So our sigma tells us that we're adding numbers together. The AI tells us that the numbers we are adding are called, there are terms, which remember are your A1, A2, and so forth, keep on going on and so on. The sum begins with A1 every single time and ends with A to the N. Okay, the sum is going to begin at the bottom, whatever that bottom one is. Usually it's A1, but it could be if the bottom number is a 0 or a 5, whatever it starts with, and goes to whatever our top letter is in our sigma notation. Okay. Whoops, this should be sigma. This should be at N, whatever our top number is. Okay, so when I look at this, nope, in my Word document here, it's not coming over. This should have the sum and I equals, yours has it in your notes, I'm just filling mine in, and then it's I plus 1 squared. Part B, again, yours is already in here. I'm just making mine, it didn't transfer over to my iPad very well, making those go, and then I'll use a different color when I'm doing the answers here. So when we want to find the sums, it means we have to find however many terms we want, and then we have to add all those together. So I'm starting with 1, and I'm going to the number 6, which means we have to plug in. The first thing we're going to do is plug in 1 right here. So we would have 1 plus 1 squared over 2. That's my first term. Plus, go up by 1s every time. I started with 1, now I go to 2. 2 plus 1, 2, or squared over 2. Then I plug in 3, so 3 plus 1 squared over 2. Plus, then I'm going to plug in 4 plus 1 squared over 2. Coming down because I'm running out of room. 5 plus 1 squared over 2. And I'm going to go until I get to that top number. Our top number was 6. So now that I've plugged in the number 6 up here, I'm done. So I need to figure out what all these are and add them together. So if we look at this, this is 2 plus 9/2. If we were to figure out what all these equaled, we can use our calculator. 25 over 2 plus 18 plus 49 over 2, and you're going to get a value here. I haven't done this yet, so I'm going to do it really quick and see what we come up with. Oh, I think I forgot to hit the addition button. Go ahead and do it with me. So I got 69.5, which also you could, as a fraction, since everything was written as a fraction, is the same as 139 over 2. So either one of those would be okay answers. Okay, so you're finding each term and adding them together. So if we do our part B over here, we want to do the same thing, but this time notice my first number is 2. So I'm starting with whatever that number is. So my first term is going to be 2 squared minus 2 times 2 plus 2. Plus, the next one I plug in is 3. You always go up by 1s. Then I need to plug in 4 minus 2 times 4 plus 2. And our last number up here is a 5. So that when I plug in, I forgot my squared on my 4, 5 squared minus 2 times 5 plus 2. So now I have 4 terms I'm adding. If we figure out what all these are, this is 2 plus 5 plus 10 plus 17. We add them all together, we get 34. So you can also do this in your calculator. So if you have, I use the TI-84 Plus, but just as a note, I'm kind of going to talk you through how you could use this. But if you go and hit the math button, and then you're going to arrow down and you'll see where it says summation. and you click on that, notice it gives you exactly what your thing looks like with the sum. So you can fill it in. It doesn't matter what variable you use right here. I use the x because it's the easiest to put in. It starts at 1, goes to 6, so put in those numbers. And then in here we would have our parentheses, and we would just do our x plus 1, square it, and then divide by 2, and then go over and hit enter. And notice it gives you that 69.5. So they can be done in your calculator also to help check your work. Something asks you to show work, you need to show some work out here, but you can check it by plugging it into your calculator. If you have calculator questions, come see me. I will show you and help you out on that. So the last thing we have right here is writing each sum using sigma notation. So here I'm giving you all the terms, and we want to write it in the sigma notations like what started up here, kind of going backwards. So again, this is another that sometimes there's more than one right answer, and that's okay. You just have to pay attention to that. So what we want to do is we want to write it with our sum. You have to pick a variable. I don't know why. I just like using k. What is k going to start with? And figure out what needs to be in here that when I plug it in, I get these terms. Well, this one's pretty simple. I have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed. So you know the cube is staying the same. Okay, and then I'm plugging in, I go up by ones, 1, 2, 3. So here it's just the k, and I'm cubing it. And I started with 1, and I ended at 7. So this is just our answer. Okay, try to see what's the same in something, what we might need to change, and go from there. Okay, part B, again, I want to do a sum. This one, well, this one, because it ends over here at n, not a number, I know this top one up here has to be an n. And then we're going to look and see, well, what's kind of the same or what's not the same. Well, if I look at this, I can tell right away that I always have a square root on top, right? And on bottom, I always have something squared. Well, notice also in the top, I'm going 1, 2, 3. So that's just starting at 1, and it's my k. On bottom, 1, 2, 3. Look at them separately, it's just k squared. So this is our function or our sigma notation. So our last one, again, whenever you have fractions, okay, this time I'm going to do my k equals, and then I'm not going to know exactly what we're doing, but kind of look at what is happening every time. So I'm not starting at 1. There's no 1 in there, so it's possible that this k doesn't start at 1. I go 2, 3, 4, 5, so I'm going up by 1s. I'm also going up by 1s on the bottom, 3, 4, 5, 6. The bottom ones are bigger than the top. Well, let's just kind of do some thinking. Here I have 2, I add 1, I get 3. 3, add 1, I get 4. 4, add 1, I get 5. So maybe this is k, and this is k plus 1, because the bottom I'm adding every single time because it's 1 bigger. Okay, well, let's see if that works. Well, if I make this a 1 and I plug it in, that would give me 1 over 2, right? That would give me that my first term would be 1 over 2. Well, that's not my first term right here. That doesn't mean it's wrong. It could just mean, well, this doesn't start with 1. Well, okay, what if it starts with 2? Because my first number is a 2, right? So if I start with 2, that would mean I'd plug it in, I would get 2 over 3. Well, that works. Go up by 1, plug in 3, I get 3 over 4. So now we have to decide, all right, it's working, what do I go to? Well, I go to whatever, my top number is 5, right? So this is going to go to 5. This is one possibility. I will tell you if you were going through it and you thought differently, another correct answer to this one would be k equals 3 to 6 and k minus 1 over k. If you plugged it in, you'd get these same fractions out. So sometimes there's more than one answer. So just keep that in mind. So that is what you guys are going to be doing today. If you have questions, please come see me. I will help you out with anything that you have questions on or using your calculator. And your assignment is on WebAssign. Have a great day.